Okay, so we're going to look at some graphs here and identify the domain and the range and tell whether it's either increasing or decreasing. Okay, so this, remember, domain is left to right and range is bottom to top. Okay, so in part A, our domain goes from -5 to +5. So that's -5 to +5. We have to decide, should we include the endpoints? Well, there is a point on -5, there is a point at 5, so we include both endpoints. And remember, it's an x in the middle because we're doing domain. When we do range, it's f of x, so we'll have an f of x in the middle. But what is the bottom point? Well, the bottom point was at -6, the top was up at 2, and again, those points were solid. We did have values at -6 and at +2. To answer, is it increasing or decreasing, you always read right to left. I'm sorry, that is exactly backwards, left to right. So from left to right, this graph is going down, so it is decreasing. Okay, B, and you don't probably know what graph you're looking at here. That doesn't really matter. We just need to ask ourselves, from leftiest to rightiest, what's our domain? Well, there is an arrow pointing to the left here, meaning that continues beyond what we see towards -infinity. But it does come to a stop when the x value is 4. So the x's can be everything less than or equal to 4. The range from bottom to top, the lowest value is at -6, but this graph, although it does sort of look like it levels off, from what you know right now, you should probably just say that the f of x values are everything greater than or equal to -6. And this graph, although you might be tempted to say it starts at this dot and increases, we don't read graphs that way. We read left to right, so it is decreasing. C, my domain with arrows in both directions, left and right forever means all real numbers. Down forever, up forever tells me all real numbers for the range. Is this increasing or decreasing? As I read left to right, it is increasing. Part D, my domain goes from, its leftiest point is 1, the rightiest is 6. So from 1 to 6, including both endpoints. The range value from the bottom of -2 to the top -1. And again, from left to right, we're increasing. E, arrows on both ends of this line say it goes left and right forever, it goes up and down forever. So domain all real numbers, range all real numbers. From left to right, it is going up, so it is increasing. Okay, domain in F is from -5 to the right infinitely. So all x is greater than or equal to, there is a point on -5, -5. The range value, now I guess we have to kind of estimate that, but it sure looks like that's at about 1/2 for a y value, and it continues to grow infinitely. So the f of x values are everything greater than or equal to about 1/2. And this function from left to right is increasing. G, we have domain leftiest to rightiest. Well, again, an arrow pointing one direction, or left and down, one side of the line. So our domain is every x value up until we get to 5. 5 is the very last one. So every x less than or equal to 5. The range values, we have everything below this red dot and way beyond what we can see in the graph. So the highest, there is no lowest y value, but the highest is -1. So our f of x values are everything less than or equal to -1. And even though the arrow is pointing down, again, we only read graphs left to right. This function is increasing. H, arrows going right and down, up and left. Now, you might recognize this as an exponential looking graph, but we don't have that information to say for sure. So we're just going to assume that it does continue decreasing even below the x-axis. We're not positive of what this graph is right now. So the domain is all real numbers, the range, all real numbers. Left and right forever, up and down forever, maybe. Is it increasing or decreasing left to right? It is going down, it's decreasing. All right, and number 2, we now have to look at either a common difference or common ratio. So we're looking for the pattern, and then we're going to try to make the equation. So the 2 types would be linear equations, which have a constant rate of change, and take the form y equals mx plus b. And the other type of function you'll see is exponential, which is a common ratio or a multiplier, and take the form y equals a times b to the x. Okay. So in this first one, in part A, we notice our pattern. This goes up 2, then up 2, then up 2. So that means we have a constant rate of change of 2. So this has a, I'm sorry, on here this worksheet's calling it a common difference. We called it a constant rate of change, same thing. Common difference is 2. And our equation then is, we could use y equals or f of n equals. F of n equals, we take that constant rate of change times our independent variable, and then we need to add on the y-intercept, or the 0th term. So let's take this pattern back one more space to get to when n equals 0, the y value, if we had been going up 2, we would have to decrease 2, it would be 1. So 2n plus 1. Part B, we look here for a pattern. We see it goes up 4, but then up 8. So it's not adding a common difference. How about multiplying? That's times 2, times 2, times 2. So there we have a common ratio is 2. So a common ratio of 2. Okay, well then that takes the form f of n equals, now in these exponential ones, we start with our y-intercept. That comes right after the equal sign. So I'm going to have to go back a couple of steps to get to my 0th term. If I went back one step, that would be when n is 1. To go backwards, I would have to divide by 2 and a value of 2. If I go back another step to the 0th term, take that pattern back again, I'm at 1. So 1 times the b, y equals a times b to the x. The b stands for the common ratio, which is the 2, and then it's always exponential to the n power. C, looking for a pattern again, it adds 2, then adds 6. It's not linear, so let's try multiplying. That's times 3, times 3, times 3. So yes, we have a common ratio of 3. That makes this exponential. So we're going to say f of n equals, now we need our 0th term. If we go back a step and reverse this pattern. Instead of multiplying by 3, I'll divide by 3. So 1 divided by 3 is 1/3. 1/3 times the multiplier, which was 3, to the n. Part D. Down 4, down 2. It's not a common difference. Can I multiply 8 by something to get 4? Well, 8 times 1/2 is 4, and 4 times 1/2 is 2. So this one again has a common ratio. This time it's 1/2. My equation, f of n equals, I need the y-intercept, the 0th term. So if I go back a step in the pattern, instead of multiplying by 1/2, I would multiply by 2 over 1. So this is 16. 16 times the common ratio, 1/2, to the n power. E. Notice we're not starting at 1. So when we look for a 0th term, we're going to have to go back 2 steps. But what do we see here? This goes down 8. That goes down 8. So we are looking at a common difference of -8. So to make our equation, we start f of n equals that common difference, that constant rate of change, -8, times the independent variable, and now we need to add the 0th term. We'll go back a step to the first term. I would have to add 8. That's 48. Go back another step to the 0th term. Add 8 again. I'm at 56. So plus 56. And lastly, part F, I see adding 6, adding 6. So we have a common difference of 6. Linear equation takes the form y equals mx plus b. So f of n equals positive 6 times my independent variable. Now I need the 0th term. Again, I started with the second one, so I'm going to have to go back 2 steps. When I go back 1 step to the first term, that means reversing this pattern and subtracting 6, I would be at 1. Go back another step to the 0th. Go back another 6 puts me at -5, minus 5.